Well, hello friends. Welcome back to language hacking. Today we're going to work on the self-hosted Jakt compiler. So that's Jakt implemented in Jakt itself. And the compiler is coming along nicely. It can compile hello world, but nothing super complex. So today we're going to be improving type checking by implementing the while statement. So we're going to learn how to compile a program something like this, maybe. Hello, friends. Yeah, something like that. Should be doable. So first thing we got to do is just make sure we build a baseline compiler. So this is the compiler written in Rust. And then what we do is we want to build the self-hosted compiler, and you do that by running the baseline compiler on main.jakt. And it got killed by, I actually have a background service that runs in the background on my machine and just kills anything called Jakt if it runs for too long, because I am a little bit paranoid that one of my compiler processes is going to sort of run away and allocate all the memory in the machine and then screw up the video recording. So it's essentially just every 15 seconds it will kill anything named Jakt. So we might see that one again, but that's what that is. Now we have the self-hosted compiler, so that would be here. This is how we invoke it, and we want to run it on this little test program we made. So first we can run it with -L to see the Lexer output, and that shows us all the tokens that we lex. Looks reasonable. We can also run it with -P, shows us the parse tree that we get. So the parse tree looks pretty reasonable. So we have a namespace with a function called main. That function has one block with a while statement. The guard is a Boolean true constant. And while that guard condition is true, we should run this block right here, which calls println with the quoted string hello friends. So that's pretty much the program that I typed in. And we can see here that when we try to run the compiler, it actually aborts and says to do type check statement else. And that is going to be a little to do message left behind by myself or somebody else working on the compiler. Yeah. So here we are. And this is where we're going to start today. So if we run with P, we can see the parsing output. And this actually doesn't show us which type of statement is unimplemented here. So let's just print that out. Statement. Oh, and of course we have to rebuild self-host if we make any changes to it. It takes a little while to build it, but 99.9% of build time is in the C++ compiler. So the Jakt compiler just transpiles to C++, and then we pass it over to Clang. And then Clang takes a hot minute to compile sometimes, but it is what it is. All right, so we can see that the failing type check is on a while statement. So we need to add while statements right here to this type check function. So let me run with -P actually for this nice indented output. Shout outs to Sam, I think it was Sam who did the indentation thing, and maybe somebody else worked on it as well. But yeah, so we have, where's that while statement? Right here. So the while statement has a guard, which is the condition. I don't know why it's called guard. I would have maybe called it condition, but whatever. So while the guard expression evaluates to true, and then it has a block as well. So those are the two things that we care about. Guard and block. And then let's just pass this to type check while guard block. We're going to make a function for this. We'll pass in the current scope ID and the safety mode. All right. So let's implement this. Type check while, and that's going to look something like this. So guard is a parsed expression, and the block is a parsed block. And we have the scope ID and the safety mode. This might throw because we're going to have to allocate in some cases. And it will return a checked statement. So it's going to return a type checked while statement. Okay, so what do we need to do here? We could look at what the baseline compiler does, the one that's written in Rust. I guess that would be sort of what I would typically do. So let's look at that. How did we do this? So while, that would probably be here. Yeah. So parse statement while, here is called a cond rather than guard. Okay, so the first thing we do is we type check the guard condition, and then we validate that the guard condition results in some kind of Boolean value. Otherwise, that's an invalid guard condition. And we also check if the while block is yielding anything. And then we return, wait, what was this diff? Oh yeah, we have to type check the block as well. Okay, so essentially checked guard is going to be type check expression, and we're going to pass the guard expression to there, and the scope ID and safety mode come along nicely. And then we can also check the block. Check block is type check block, and this one was called just block, I think. Yep. Safety mode, sure. And finally, we wanted to return a checked statement while. And probably these are called something slightly different. So like that, right? Yep. Yeah, so I'm going, instead of compiling every time here, I'm just going by the red squigglies and also the problems output down here, because we do have some basic but very helpful IDE support for Jakt. And I'm using our own VS Code extension here, which gives me stuff like code completion and live warnings and errors and stuff like that, which has been really helpful in just getting comfortable with using the language. Okay, so now that we have those, in theory, that should be enough to compile, although we're not doing the diagnostic stuff. Let's see if this is enough to actually compile the program. Oh, there's that paranoia process killer. Come on now, there we go. And that was apparently enough to at least generate some output, although I don't see a while statement in the output. I just see kind of a goofy empty block right here. Let's pass this through Clang format just to make it a little more readable. Okay, so we are definitely missing cogen for while statements. Let's see, while. Oh, while is right here. Interesting. So is this cogent statement? I think we're going to have to dump out the resulting thing here, because I would have expected this to produce some kind of output. Let's see. So I guess we can, why don't we just print it right here? Guard, checked guard. Now this is something I love in Jakt already, by the way, that every object, like every struct, every class is printable by default. Like they have a built-in serialization thing. You don't need to do any macro tricks or any manual pretty printing. Like it just gets built in by the language itself. So even if you have like complex objects that contain other objects and things like that, this will just work. So let's see what it says. This thing is kind of annoying because like whenever I start compiling, there's a decently high chance that I'm going to get killed. So I have to do it twice. At some point, we're going to need some more sophisticated thing than having a background shell always trying to kill. Anyway, so what do we have here? Oh, now we are getting some more output, right? Of course. So the guard is a checked expression Boolean. That looks fine. And the block, so everything here looks good. Why does this not result in a while statement in the output, I wonder? That's kind of weird. Maybe we're not even generating the code, or we must be. Let's see, cogen function, sure. Okay, so here's main, here's the argument, parameters, blah, blah, blah. Where is the actual block? Right here, cogen block, okay. And for each statement, we will cogen that statement, sure. So let's see here, block statements iterator. Will cogen statements. And I guess we can log how many there are and then also log the statements. Okay. Yeah, and the big reason why I have the background killer is because the whole IDE extension, all the IDE features are based on running Jakt. Like whenever anything changes in this file that I'm editing, we run the compiler and do like a type checking and hinting only pass. So I'm constantly like spawning little Jakt processes, and if any one of them would like go haywire, it could ruin my recording. So that's what that's about. Okay, let's take a look here. Will cogen one statement, sure. So this is the outer function block, has a while statement. Then the inner function block, or the inner block of the while statement, has a call expression to print line, sure. Cogen block. See, that looks very reasonable. So why cogen statement? Mute up. Oh, wait, are we... It's just falling through here. It's not actually... It's just falling through to the bottom. See, so we create an empty string, populate the empty string, and then we just fall out and return empty. So the fix is to do that. It's kind of silly. And actually the loop statement here has the same bug. And if, oh, they all have the same bug. Well, that's very silly. I guess maybe a better fix would be to like put this up here potentially. Although no, let's do it this way. And then just make sure that all of these match cases return. Should be fine. Okay, so let's close this stuff. Take a look. Yeah. As you can tell, like it's still very early days in the self-hosted compiler. We decided like a week ago or so that we would stop development of the baseline compiler written in Rust and just focus all efforts on self-hosting instead, just to, dang it, just to try to mature the language quickly, mature the compiler, and then get self-hosted as soon as possible. And then go back to like inventing new features and developing new features once we are self-hosted. And this is so silly. Maybe I should have set a longer time, but there we are. Okay. So this actually generates something more what I expected here, right? So if I put that in a file by itself and let's try to compile it. Hey, it works. Yes, it's like those early basic programs, you know, 10 print hello, 20 go to 10. It's kind of like that. Okay, so let's see here. First thing is we're going to get rid of our little debug statements, debug printouts. Not you. You can go away. Not you. Okay, and I think we're going to commit the bug fixes to code generation first. Self-host code gen. Fix bogus return values. Like, in codegen statement, we are generating code and then falling through and returning the empty string instead of what we just generated. Oops. And then, so this is still incomplete though, because we also need to add the diagnostics. So, before we do that, I'm just looking at this function here, and there's a bit of there's a bit of indentation, like a little too much indentation for comfort here. One thing that we're trying to do with Jakt is find ways to avoid excessive indentation. And I mean, it gets way worse than this in some places, obviously. Also, I don't know why this is indented here as a separate block. That doesn't seem necessary, but we have this one little trick that we have been playing with, which is when you have a function that starts with a match statement and that match statement sort of spans the entire function, what you can do is you can take that match statement and just yoink it up to the the first line, because we have this thing called fat arrow functions in Jakt, and the way they work is like this. So this is a function that returns 5, and you can put an expression after the fat arrow, and that will be the return value of the function. And since the match is an expression, it can go there. And what this allows you to do is, for these match-dominated functions, you can actually put the match on the line with the function and de-indent everything one step. And it was a little bit weird to me at first, but I grew to really like it. I think JT invented this. And of course, now we can't return down here because we are still inside the match expression right here. So the match has to be exhaustive, and it just ends up looking something like this. And you are mad because not all paths return a string currently, or yield a string rather. So let's see. So here we would probably just do something like this. You can be like that, and instead of returning, we want to yield. And the yield keyword is currently only used with match, and basically in Rust, what you would do is, in Rust they have this magical thing where the last expression inside of a match case or match arm or whatever becomes the result of the match expression. But it's kind of awkward in Rust, and like, I know that even people who have been using Rust for many years say that they still screw that up regularly. And I don't know. What we came up with for Jakt was that we would just have a keyword, so that if you want something to be the result of the containing expression, then you yield the result from inside. And I don't know, I find it, it sort of solves the problem in a more expressive way than any of the other options I've seen. So that's really nice. One problem we have currently with our yield is that if is currently not an expression. So we cannot yield from inside if. It will be upset about that. So, and by the way, here you can see an example of live errors in our IDE support. An if block is not allowed to yield values, right? So we have to essentially do something here, like, I guess, I mean, one thing we could do is something like this. So this is a Boolean, so we would just do this, true would yield this, and false would yield that. Yeah, so that's one way of doing it. Match expression is not exhaustive. Okay, so this is just an example of our exhaustiveness checking not being very sophisticated, because obviously true and false are the only possible values of a Boolean. So we should probably understand that, but at the moment we can't, so we'll just say true or else. I think that's okay too. And oh, and by the way, yielding is automatic if you use a fat arrow with a for your match case. So this fat arrow basically says yield this expression as the result of the match. Okay, so we'll just do the same thing here. Okay. And match expression has value. Yeah, we're definitely gonna come up with some nicer patterns for some things like this, but it's already kind of interesting to see how this evolves. sort of the patterns that evolve over time as you start to play within the constraints of a new language. I've been just having a really good time seeing that process from my own experimentation recently. Okay, so let's make sure we yield everywhere. That we can. So yeah, so here's an example of a little cleanup that you can do. Like if you just want to yield an expression like this, you don't need to make a block that has a yield. You can just skip the yield and do a fat arrow right away like this. Okay, here we can see a problem. Our language does not have a concept of no return or functions that don't return. Panic does not return, but the language doesn't know that, so it expects us to yield something here. Fix me, panic should be no return, and no yield should be necessary. And likewise down here. Okay, so what did we achieve? Well, we de-indented the function, so it's one step to the left, and I think it came out slightly nicer, so that's good. Let's see. Self-hose, cogen, refactor, type check statement to reduce indentation. Use JT's fat arrow match function trick. I don't know what's a good name. Fat arrow match function. FAMF. I don't know. That's kind of what I think of it as. It's a fat arrow match function. And we have a whole bunch of these. Oh, I'm almost committing this now, by the way. We have a whole bunch of these things in the code already. So we have been making, let's see, making good use of these things. Like here's one. The parser is full of them because they're so, I don't know, they're just so nifty. Anyway, let's see. So I wanted to fat arrow match function trick to avoid to indent one level. And let's get rid of that function foo thing that I put in there. Yeah, we don't want that. So amend previous commit, sure. Okay, so back to type checking. Where were we? Right, so I wanted to do the diagnostics on the while statement. So let's have a look at that. Oh, it's right here. Yeah. And the diagnostics we had, if I recall correctly, we wanted to check that the guard expression results in a Boolean value. So checked guard dot, oh, wait, dot completion doesn't work here. Oh, wait, I think I have to call expression type on it. Yeah, there's an issue, or there are a lot of issues right now, but I remember one issue is that we can't always put like methods on enums in all situations. So we end up with like helper functions, like this one is outside of the checked expression enum, but really it should be a method rather than a free function. Also observe the FAMF pattern going on right here. Okay, so let's see. So if the expression equals built-in bool. Am I doing this right, I wonder? Wrong number of arguments. Oh. Okay. Yeah, that's not the most obvious error, but basically we should definitely improve this. But wrong number of arguments in this case, if you look, it actually shows the function above which we're calling it, and that is enough context if you know what this means. So wrong number of arguments means that we're missing the this argument because it's actually an instance method. So we need to call it on an object, and we are within type checker right here. So we can just put a dot and it becomes a method call, or it becomes an instance method call, which this is equivalent to this dot, by the way. It's just shorthand that we use throughout the language. Okay, so if equals bool, well, then everything's good. So it should be if not equals bool. And if that happens, then we want to say, let's make sure that we say verbatim whatever the previous compiler said. So type checker rs while condition must be a Boolean expression. Yes. Okay. And we can also pass in the span. So that would be the span of the guard expression, which would be something like that. Okay. And by the way, you'll notice here that just because we get an error, it doesn't mean that we return. We actually just keep going in the compiler, both in the baseline compiler and in the self-hosted compiler. We just keep going whenever we encounter errors because we want to get as far as possible so that we can present the best information possible in the IDE. Because, you know, while you're typing, your program isn't necessarily valid, but we still want the IDE features to work as well as possible, even while the program is being edited. So that's why we keep going, so that we'll still find subsequent functions and other statements that are like after the error, and hopefully annotate and highlight them correctly. Okay, so that's that error. And then we also wanted to check for, oh yeah, so this issue here, we're checking if there's a yield inside of the block. And if so, we error about that as well. So if checked block dot yielded type has any value, then we will log an error about that as well. Find yield span in the checked block. What's wrong with that? Unknown function. Find yield span. Wait, what? Oh, that's a function of the parsed block, not the checked block. And then it returns, right. So what this does is, what find yield span does is that it gives back the exact location in the source code of that yield that's not supposed to be there. But if there isn't any, then it will return an empty optional. But we know in this case that there has to be a yield because we know what type the yield yields. So we know the optional is engaged, and we can therefore unwrap it, force unwrap it like this. So here we'll just say while block is not allowed to yield values for now. All right, and I think that should do it. Oh, but we can we can of course test this. So we should check that you can't while something that's not a Boolean. Okay, so how would we do that? Let's see. How do we get something that's not a Boolean that we can actually cogen with the self-hosted compiler? Maybe I can put a none here or something. No, it liked that. Must be a Boolean expression. Okay, so why does it accept that? That's interesting. Type checker. Must be a Boolean expression. So if it does not equal built-in bool. Okay, so what does equal actually do? Type ID checks that they are identical. Wait, what? Okay, let's see. Type of guard. Expression type of checked guard. Let's find out what that is. Yeah, this thing is happening a lot more than I expected it would. Okay. So what does it say? Type of guard is type ID in module 0, ID 1. Okay. And what are the built-in types? Here. So bool is 1. Wait, so it actually gives back a bool? I'm guessing that we just have a bug in the way none works then. Optional none. Oh, new inference. Oh, this is interacting with the inference system, which I actually don't even know how it works yet. I didn't dig into that. So we should probably just find another way to do this for now. We can maybe use a numeric constant instead. So let's do that. Let's just put a numeric constant here. So 5, for example. Yes. Okay, here we go. This is not a Boolean expression. Unlike C or C++, we don't consider integers to be like implicitly convertible to Booleans. You have to actually say something like while 5 is not 0 or whatever. But yeah, as you can see here, the error reporting works nicely, and it looks really, really sweet actually with the highlighting. And then we also wanted to check that you don't yield 5 in here, because that should not be allowed either. Missing statement cogen. Okay. Oh, right. I bet that that's not even hooked up. Like, we probably don't notice where the yield thing is done. The yielded type thing. Yeah, I think that's probably never populated. Not yet, anyway. Yep, looks like it. So let's just ignore that for now. But we had that type of guard thing. Okay. Here we go. Okay, that's pretty good. So this will be our while type check. Self-host type checker. Check while statements. The diagnostic for while for non-Boolean expressions works, but the yield error doesn't, since the yielded type metadata is not populated yet. Yeah, that's that'll just start working once we start populating the information about what a given block yields. So I think that will probably, I was going to say that will be the end of today's video, but it would be nice if we could also break out of this loop. And I think break and continue are really easy to implement. So we can probably do this one by just, let's see, if we look at the way it's done in the baseline compiler, I think break, yeah, right here. So like continue and break, they just generate checked statement, corresponding checked statement without anything fancy. So I think we can do the same thing here. Checked statement, continue. Also, the syntax highlighting for enums like these doesn't seem to understand when I don't put the parens. So the parens are not required when you're instantiating an enum or specifying an enum variant, but it seems like the syntax highlighter thinks that because there are no parens, it's not an enum variant, but it should actually look like this, not like this. Anyway, that's we're not going to get distracted with that right now. So is it really this simple? If it is, then we should be able to run this program and get a single printout. Let's see. All right, build main w clang format. Looks very nice and tidy. See, we got that break right here. It out. Yep, just a single printout. So very good. We got while statements up and running. We got break and continue. We did some nice little de-indentation cleanup. Oops. Yeah, I'd say it's a decent little hack session. So check break and continue statements. Yes. So that'll be the end of today's video. If you made it this far, then thank you so much for watching. I hope that you saw something interesting here and got a little bit of a view on what's going on with the self-hosted Jakt compiler. I have been working on this exclusively for the last couple of weeks, and it's a lot of fun. And I really just want to get this thing up and running so that we can get rid of the baseline compiler, get rid of the Rust dependency, and then we will be sort of shifting gears. Once the compiler can build itself and pass all of the unit tests, and we can shift gears and start continue improving the language. And we have certainly learned a lot of things about the language while building the compiler, and there are a lot of things that I want to change or improve, but I'm just kind of holding off on that. So if anybody wants to help out with the self-hosted compiler, there's obviously a lot of things to do. We do have a large test suite, and the compiler itself is also a great test case. But yeah, that's what we're doing right now. So end of the video. Hope you found it interesting. And thank you so much for watching. I will see you next time. Bye.